Hello and welcome to a new video. It has been a while since I uploaded a video, but here I am. So let's continue with the competitive programming with LLMs series. This is episode 6, and today we're gonna compare a bit more in depth the two best programming languages that we found in our previous searches in the previous videos. So those are Vlang or B and D. I would put B on the first place and D on the second place. But we have to do a lot more testing to understand and to see which one would be better. Why I like B better than D? Well, basically because of syntax, really. Is less verbose and easier to work with. A simple thing that I mentioned in the previous video is that on a B, you can just do this, what I'm selecting right here, which is like $index to do a template inside println. And on D, you have to do this strange syntax, and that's not that good. And also on D, you have to end every line with a semicolon and other things. But today, what we're gonna do is try to compare it in other things, probably in multi-core programming, especially, I guess, what are the mechanisms for doing more than one thing at a time, which can be, multi-thread or like concurrency or asynchronous programming, like coroutine programming. So I have opened a couple of web pages that may help us defining that. Okay, so here we have an LLM, and what I'll do is I will open B and D documentation about threat and that kind of thing. So here we have a concurrency in B. It says B's model of concurrency is going to be very similar to Go. For now, spawn foo runs foo concurrently in a different thread. Or so maybe, I don't know if this is finalized yet, since B is a new language, but that's why we're here. I think I have copied this code. So we have a P thing, a P function that will be called by main using the spawn. And it says P will be run in parallel thread. It can also be written as follows: spawn fn. Oh, okay. Okay. Let's try to do that. Okay, let's try to do this. It says, note, threads rely on the machine CPU core threads. Be aware that OS threads spawned with the spawn have limitations in regard to concurrency, including resource overhead and scalability issues, and might affect performance in cases of high thread count. There is also a Go keyword. Right now, GoFoo will automatically be renamed via BFMT to spawn foo, and there will be a way to launch a coroutine with Go, a lightweight thread managed by the runtime. It says sometimes it is necessary to wait until a parallel thread has finished. This can be done by assigning a handle to the started thread and calling the wait method to this handle later. Okay. This approach can also be used to get a return value from a function that's run in parallel thread. There is no need to modify the function itself to be able to call it concurrently. Okay. If there's a large number of tasks, it may be easier to manage them using an array of threads. Okay. It says, additionally, for threads that return the same type, calling the weight on the thread array will return all computed values. Additionally, for threads that return the same type, calling the weight on the thread array will return all computed values. Oh, it will wait for all values to be computed. Probably that would be a better way of saying it. Channels. Channels are a preferred way to communicate between threads. B channels work basically like those in Go. You can push objects into a channel and on one end and pop objects from the other end. Channels can be buffered or unbuffered, and it is possible to select from multiple channels. Syntax and usage. Channels can have the type of chan object type. An optional buffer length can be specified as the cap field in the declaration. So we have ch-chan int array unbuffered synchronous, ch2-chan f64 cap 100, buffer length 100. Okay. Channels do not have to be declared as mute. The buffer length is not a part of the type but a field of the individual channel object. Channels can be passed to threads like normal variables. Okay. Objects can be pushed to channels using the arrow operator. The same operator can be used to pop objects from the other end. The arrow operator. I don't know how to make this thing with my keyboard. A channel can be closed, I guess, with less than and minus. Is that what? Is that? I don't know. A channel can be closed to indicate that not further objects can be pushed. Any attempt to do so will then result in a runtime panic, with an exception of select and try push. See below. Attempts to pop will return immediately if the associated channel has been closed and the buffer is empty. This situation can be handled using an OR block. Okay. For clarification on this, we'll ask ChatGPT, what are channels in the context of concurrent programming? In the context of concurrent programming, particularly in languages like Go, channels are a communication mechanism to use to synchronize and transfer data between the Go routines, like with threads. Here are the key aspects of channels. First, synchronization. Channels help synchronize the execution of Go routines, ensuring proper sequencing. Data transfer. They allow the sending and receiving data between concurrent threads safely. Blocking. Operations and on channels send and receive block by default until the other side is ready, ensuring data integrity. Do you need information about implementing channels about the specific language more details on? I don't know if this will work. Trying to compare Vlang and Dlang in this lightweight thread scenario. Got it. Here's a brief comparison of how Vlang and Dlang handle lightweight threads in concurrent programming. Vlang uses coroutines, which are similar to Go routines in Go. Channels. Vlang provides native support for channels, ensuring simple and efficient communication and synchronization between coroutines. Ease of use. Vlang aims to provide a straightforward syntax and approach, making concurrent programming more accessible. So here we have a B thing, which I don't know if it's okay, it will work or not. Oh, this is the the arrow operator. Dlang. Concurrency model. Dlang supports various concurrency models like fibers, D native lightweight threads, OS threads, and message passing. Channels. Dlang has STD concurrency module that includes message passing capabilities similar to channels. Flexibility. Dlang offers more flexibility, but at the cost of complexity. It allows you to choose the most suitable concurrency model for your scenario. Key considerations: simplicity versus flexibility. Vlang concurrency model is simpler and more intuitive, while Dlang offers more robust and flexible options. Performance. Both languages are designed for high performance, but Dlang flexibility might give it an edge in complex scenario. Ecosystem and support. Consider the community, libraries, and tools available for each language, which might affect your project's development experience. Okay. So let's compare these with the other thing. So I will copy this and I will paste it here in IntelliJ. So this is what the LLM said. Okay. I will do the same for D. I'll create a function. I have to do void multi-core programming. Okay, and I will copy, and I have a comment in the other which says efficient thousands of threads. Is this efficient for thousands of threads? Well, we're gonna find that out, hopefully. And then we have something here like this, which calls something else. In this case, this. I'll put it here, and has a import concurrencies. Okay, so let's see. Okay, let's see if there's some error. No errors found in this file. Okay, that's great. So main is what gets executed. Well, I will keep this average thing for now, and here after that I will say multi-core. It's not helping me call this guy. It's not helping me with auto-completion. Why? Not sure. Multi-core programming. Is everything okay? Well, we will see. What is this thing doing? It says auto-tid spawn worker thread. And what I'll do is here say OL TID. Oh, and I don't know how to do the other thing. Yeah, I guess it's this to string. I'm just copying what I have above. TID. Is that good enough? And with a semicolon. I don't know. Hopefully. What will this do? Will spawn a lightweight thread, which is worker, and this TID, I don't know what this is. Oh. Okay, it's like this process ID, should I say. And then it says parent TID sent 42. Write ln received that. But write ln is the same as OL, right? Probably not, will not work. Will that work? It won't. Okay. Int, but can I change this just to something for testing purposes, like instead of a string, make this an int. Will that work? I don't know. No errors found. Okay, so this will send 42 back to the parent TID, which is, I guess, this thing, right? And we'll print that out. I don't know. Let's run it. And it says TID and says 42. Okay. Okay. Let's do the same in B. So here we have the implementation of binary searches. We were using it to benchmark this, which we are not going to use this right now. I will call multi-core programming. In this case, it actually found the name. So I think the plugin is better for B. Now we will see what can we do here. Run. It says 42. So this is like a message passing, you know, this channel kind of thing. We have to find a better use of this kind of thing. How can we do that? Well, at least compile them both and run in both, which is already a win, I guess. So yes. Sorry for the background noise. Okay, so what can we do now? We can probably do more things, like do more threads, right? For example, here is doing like 42, returning 42, but we probably can do something better, right? Like find you know, the square root of something, or I don't know. What can we do? Let's do a processing thing. Let's do a thing that will process something, like calculate. Okay, and we will calculate something, and we will return that. I think to return a type here, we just have to say here int or something like that, right? And to define a variable, we don't need to use var or anything like that. We just need the name of the variable. In this case, I will call it result, and I'll set it to 0. Nice syntax. Then I will return, not result, return result. Okay, and what I'll do here is I will do a for loop. Can I do something like that? Can I do like a C style for loop for I at 0, I less than 1000, let's say, I plus plus, and we will do result plus equals result. And of course this was not possible because result is not mutable, but I make it mutable with help of the plugin, which is great. And now I return result, which is kind of cool. Now here, instead of returning 42, what I can do is say calculate, right? Will that work? Well, I don't know. Let's run it. and it says is 0. Of course 0 because it's 0 plus 0, 0, 0, 0, 0, 1000 times. We'll do it now with 1. It shouldn't be 0. 1 shouldn't be 0, right? I mean, 1 plus 1 would be 2, and 2 plus 2 would be 4. And 1000 times, maybe it's too much, right? About maybe? No, I'm not sure. No, I'm missing something here. I'm doing something wrong. I will do a quick println here, and I will print result. Now I'll run it again, and here we have a problem. I don't know why that problem, what problem this is. Unknown function OL. Don't I have OL? Is it possible I don't have OL? Yeah, it's possible I don't have OL. Let me define it then. Okay. Okay. Let me remove this binary search thing. Okay. Should I make myself a bit smaller? Okay. FN OL string. I mean, is this how you define it? No. MSG string. I think this is how you do it. Println MSG. Is this correct? I hope so. Okay, now I do have a well. Let's run it again. And everything, it's always 0. Why? Why? Oh, okay. 2, 4, 8, 16, 32, 64, 128. Okay, that's too much, probably, right? I would say result modulus 3. What about that? A lot better, right? A lot better. I can now get rid of that OL, and I have 151. And now the calculate thing does something, let's say, more compute intensive. So I can do like 10,000 times just to see how long it takes. Right, again. And there you go. We can go 1,000,000 times. Well, that would take a lot longer, right? No, that longer. 10 million. Oh, why is it so fast? 100 million. Oh, okay. Oh no, I don't know why it's so fast. Oh, there it takes a bit more. Okay. Run, and takes a while, and it's done. Okay. Let's accept that. Can we go? That's a lot. 100 million results. We can do something else like result. What can we do? Plus equals result modulus 5. Okay, let's see. That takes a bit longer, as you can see. Okay, it's not that bad. But now I will put it a longer thing here, which is probably 1 billion, which is the most figures I can write for an int, right? So it will take quite a while. As you can see, it's not there. But why am I doing this? I'm doing this because I want to measure this on how much memory it uses. So probably this is the thing. It uses 2.7 megabytes, as you saw, and takes some time, right? 2.7 megabytes. Okay. Can I do the same for D? That's the question. So here, what I'll have to do is I'll say auto result. I'll set that to 1 semicolon. I have to send back a result, as far as I know. And here, I don't know how you do a thing, but probably I will just say or ask the LLM to translate these to Dlang. Translate the following B code to D. Okay. Let's see. Equivalent code in Dlang. Long. Here it uses long to avoid overflow issues. Okay. Let's not do that for now. Let's just learn it at our pace. Okay. So let's see how it goes. Will it compile? It's running. It says it's running. So let's see how much memory it uses. Dlang code? Is this? 1.7? Yes, this has to be. So this uses 1.7 megabytes and is faster. So D has a smarter compiler than B. So I will run first B and then I will run D and probably D will win. All right. Okay. And let's see which one is using the most. Here we have 2.7 for B and 1.7 for D. And it's done, and it's done. I mean, almost the same, right? They gave out the same result, almost the same time. Maybe B takes 1 second longer, which in this thing may be like 5% slower, but that's not a lot, really. That's a tiny margin. Okay. So both can do this. Both return the same result. I was able to implement them for both languages. And now let's try to do more threads, right? Well, yes, I guess. Okay, I want to do this for 10 10 let's say 10 jobs. I don't know. Understood, it says. Why is it keep scrolling up? Understood. You wanted to run this code with concurrent jobs in Dlang. Here's how you can achieve this using STD concurrency module to spell define. Dlang equivalent. Okay. Do it for both D and B. Okay. So we will do this, and then we will print the result. Okay, let's see. The first thing that it does is create a channel of capacity 10, then just run this 10 times. Okay, then prints this 10 times. I mean, the usual. So will this work? I don't know, but I won't run it yet. Maybe I will compile it. Can I compile it? Yeah, it compiled. That's great. Okay, now I will see how it's done for Dlang. Okay, here you have this, and let's see Dlang. We'll comment this. Let's compile it. Okay, I'll run B, now D, and I guess this will take a while, right? But we will have to measure how they behave right here. 100th CPU usage, as you can see. 47 for B and 47 for D. D is using only 1.7 megabytes. B is using 3.4. So D has a bit more efficient, less memory consuming jobs. How long will this take? I don't know. But they are using like, I mean, as much threads as they can, I guess. I will check my CPU temperature just to see, and it's 47, which is great. Well, I have tuned the CPU to not to reach very high temperatures. Okay, and we have a result here, 0.8, and in B we're done as well. Like 5 seconds later, probably. Yeah, about that time. So performance-wise, both are almost the same. Now, the thing is that, how to say it, the memory used by the threads is lower in D. So D has a bit better performance, but I mean not that much. But now we have not many threads. How can I use more threads? I want to use more threads, but first to do that, I will reduce this thing. So I will reduce the thing by 10 in both cases, and I will increase the number of I would say n jobs. We'll set that to 10. In this case, it's 100. And here I'll say n jobs. And here I'll say n jobs. And here I'll say n jobs. I'll do the same for D. Oh, we already have this, but I will rather call it n jobs. Can I please do that? That's great, and I will set that to 100. Okay, that's great. So now we're testing something that is every call is 10 times less compute intensive, but we have 10 times as many calls. So let's see how this behaves. I mean, okay, I guess if I order sorted by CPU usage, then we have the two winners. So here we have something different, completely different. Now B uses less memory than D, which is surprising, actually. But let's see which one ends first and if there's a huge difference. But yes, so B uses 3.7 megabytes, and D uses 9.2 megabytes. There's quite a bit of a difference, quite a difference actually. So, well, both are using the whole CPU. I think I have 6 cores, 12 threads, if I'm not wrong. It almost freezes my computer. I don't know if I am if this is affecting the screen recording. Probably, I didn't thought about that. Is this done? I guess it's done. About the same time. But this is kind of interesting. Okay, now, yes, we have 12 CPUs. What we're going to do is we're going to do something more interesting. I will decrease by the big number by 100 to avoid using, that many things, and I will do one and increase by 10 times the number of jobs. Okay, I'll do the same for both, and I will see, as you can see, this is a lot faster. This is a lot faster, as you can see right here. So now I will increase by 10 again the number of jobs from 1,000 to 10,000. Okay, and I will run here and run here. And let's see if we can measure this, guys. D is using 89 or 72. D is using most of the CPU, even though I started B first, right? Well, I probably that's something about the which one was able to get those resources first. I don't know, but D is almost there. Then now B is the one that's using most of the CPU. But a lot of overhead is in printing the result. So what I'll do is I'll do some like mute result, and I will set this to 0, and here I will set result. We'll do plus equals and the result of the channel. Then I will print only one time like that, and I'll do the same for D. I say int result is 0, and in this case result plus equals, what did I do here, plus equals receive only, and write ln after or outside the loop. And now we can see how this works. Okay, let's see what happened. It's almost freezing. Okay. It's too much. That's too much. It's freeze the computer. So I don't even know if this video is correctly recorded. So what can I do to reduce the usage of these guys? I don't know. Can I restrict the max number of physical cores used? I would like to do that. Yes, both. Okay, it says. Okay. Come on. Okay. It says, yes, both Vlang and Dlang offer ways to control the number of physical cores utilized for concurrent tasks, but the methods to do so are different. As for the latest updates, Vlang does not provide built-in tools for thread core affinity directly. However, since Vlang interoperates with C, you could use C functions to set thread affinities. Here's a general approach using C for core affinity integrated into Vlang. This example assumes you have familiarity with C programs and system-level programming. I have familiarity with C, but not a lot with system-level programming. Okay, so we have a thread affinity right here. That's the code integrated with Vlang. It says C thread affinity. Okay, I guess this has to be saved in a C file. Am I assuming correctly? I don't know, but let's see. Let's see, right? Should I move myself? What? Oh, I'm resizing this thing. Okay, here I will create a new thing, which I will call file core.c. I'll call it that way. Is this should be .c, should be .h? I don't know. But there we go. Now I will go and continue to see if I can do this. I don't know if I can do this. I'm trying. This is improvisation, experimentation. Integrate with Vlang. You can call C function for Vlang. You will include this C function in a separate file and link them during compilation. Please tell me how to do that. Then, okay, and calculate set thread affinity. Worker set thread affinity. Limit core usage to 4 cores. Okay. I will copy this and I will paste it somewhere around here. I guess, I don't know, but here, does this include something? I don't know. Worker ID set affinity, C set affinity ID. Well, I don't know. Where is this doing? Inside the worker. Worker. Do I have worker? I don't have worker. Let me delete these guys. I don't really know. Don't really need them. So worker is the thing that calls calculate. So I guess no, actually the thing that returns calculate go worker. Go and this, so I guess I have to call it from here. I guess. Will this compile? No idea at all. Dlang provides more direct control over threading and can utilize core affinity settings through external libraries like core.stdc.stdio for C interrupt. Here is the approach using core.cpu ID. Setting affinity with Dlang. Okay, so this is a lot easier. So I would prefer to start with Dlang since it's easier. Okay. It says that something is wrong. Let's just move this to the top. Okay. Integrate with workers. What happened? This thing scrolls like crazy. Okay, workers, spawn, set thread affinity, worker. Here we have a worker. Do we have? Yes, do we have one? Set thread affinity core ID. I will run it just to see if. Okay, I will do this and copy this. This is a lot more, difficult to deal with these things. Apologize for that oversight. Let's correct the Dlang example with proper usage of the required modules for setting thread affinity. We'll use core.thread affinity for setting core affinity as part of the standard library. Here's a corrected version of this. Import core thread. Okay. Thread get this set affinity core ID. Will this work? We'll see. We'll see. Okay, probably it's better, looks better, but still not sure. Set affinity. It's not, that's not the way you do this, I guess. It says that there is no thing like that. Thread. Let's see if I have something like affinity. It doesn't have anything like that. So that's the thing, right? That's the thing. Maybe if I search in the official documentation, probably I will find something. I don't know. Let's see. Here we have the concurrency. Let's say Dlang thread affinity. Let's see if we find something. We have slow internet. Come on. Class thread. Core thread. Module thread. How to see if affinity pre-thread. This class encapsulates our threading functionality in the D language. D is burning priority. Default priority max is daemon. Daemon is the main thread. Methods get this. Join slip, get all, get this, apply, hash. So it doesn't have like affinity kind of thing. So let's say fiber probably. Always independent live with threads like aka fiber. Class core thread fiber provides this. State call get is result, yield and true, factory. To hash enums retro, derived counter, derived counter term. Okay, so that's not working. I would say just that. That is not working. What should I say? Set affinity does not exist. Okay, thank you for mentioning that. Let's address thread affinity in Dlang correctly using core CPU ID and correct method to achieve core affinity control. Okay. Set thread affinity. Maybe this one will work. We don't know. But we will copy these guys. Actually, copy all of them. So it looks like D is better for this, apparently, but still not completely sure, right? Okay, copy those imports, then set thread affinity. Okay. Still not there. CPU set undefined identifier CPU 0. So just run it and let's see what can you say about this. these LLMs are not the best, you know. If you ask them these kind of questions, they find it quite difficult to do. It says, my apologies for the confusion. Let's create the Dlang sample to properly use thread and CPU affinity setting mechanism. Here's a correct approach using courses POSIX chat for setting CPU affinity in a POSIX compliant system. Okay. Whatever. Let's see. I don't know. I don't think this is gonna work either. I think it's giving me the same code, or not. Yes, I mean this is not something that I will continue to use time on, right? I will just not continue to use time on this. So what can I do here? Okay, so if I want, is there another way that I can do it manually, like manually limit the thing, manually limit the number of threads this thing can use? Well, I guess I can. So if it starting, I'll use like 3 threads or 3 cores, whatever, and we'll see how it works. So probably, I don't know if this is good or not, but I will do the following. I will do int active jobs 0, and here I will say while active jobs do we have while in the, I don't know, active jobs are greater than, I'll do another int max jobs max active jobs is greater than max active jobs. I don't know, this is, naive way of solving this problem. What we'll do here is we will sleep how to sleep in D and B. Thread sleep thread sleep 2 seconds. Is this how you do it? I don't know. And of course here active jobs plus plus, and but that's not how it should be done, right? Man, I'm doing not very smart things, Let's just do something else. Let's just forget about this for a minute. Let's also forget about this, because this will not compile, right? I don't think this thing will compile. Yeah, man. This will not compile. Okay. Okay. Let's. I mean, no, because they are too. It's too very expensive to do this. Only one uses all of them. as you can see. It's like all of it, which we don't want that. How can I limit the number of parallel jobs without using APIs but manually? To limit the number of parallel jobs manually, without relying on APIs, you can implement a simple job queue with a worker pool mechanism. Here's an example how you can approach this. Achieve this in both Dlang and Vlang. In Dlang, we will create a simple worker pool that processes a limited number of jobs in parallel. It says, while true, receive, init, worker received job, simulate some work with sleep, send job. Main max parallel jobs, num jobs, max parallel jobs 3, spawn for each 3 workers, spawn this ID. While completed jobs, worker and job, we do send spawn worker workers. Okay. I don't know if I like this, but okay. In Vlang, worker Each worker waits to receive a job, an integer representing the job ID from the jobs channel. Okay. Main function max parallel jobs limit the number of simultaneous jobs. We create worker coroutines that operate on the job channel. Okay, you know what? I will just end with this. End the video with this, trying to do this. Okay, so let's see if I can do this. So here we have a worker, have main, we have all these things. Okay, so let's copy these guys, right? I hope this will be okay. Will this work? Well, I don't know, but let's see. Let's see if there's a syntax error or something. So warning, probably that's because of duplicated like things. Okay. Things that I don't want to use all the CPU power. I want to limit that. Okay, that's why. Okay, result, receive only, it says worker. Okay, worker. Okay, sounds good to me. Okay, let's comment this now. And now what? Okay, so let's run it. Can I run it like directly now? And let's see how much CPU it uses. It will take longer if you use less CPU, right? But it's not using any. Why is that? Hell, I don't know. Probably is not too big. It's done because it's done, right? It does not use, is not doing anything because it's done. Right, I guess. Okay, let me copy this. It says jobs completed, but it's still not saying jobs completed. Right. I don't know. Okay, probably there it has some bug. Probably not. Okay, let's see. It has result there. Here I will do result. So I don't have the result variable ready. Right? Yeah. Receive only. Where's receive only? Here's receive only. So result should be here. Result should be okay. Result. The ID support for B is a bit better. Receive only. Result plus equals. Okay. Right ln. And here we have a problem. Defined identifier. I don't need this. Okay, let's see what happens if we run this again. It says running, but it's not working. Why can that be? Okay. Starts the first jobs, like the first number of jobs there, which is like okay, I guess. Right? Yeah, I don't know if I can see if this thing is running, but probably it's not. It's not, right? Yeah, because, I mean, it should say hello universe, and it's not saying even that. So I don't know what the hell am I doing here. Probably I have to import other things. Will that be the problem, really? Hopefully not. But let's see. Okay. I mean, the issue is that this has different worker. I have to update the worker as well. I hope that's the issue. Okay, so worker and worker received job, trip sleep. Okay, instead of that, we will do this, and instead of doing this, we will do this, and instead of doing this, we will do this, and we will delete this, and we will run this. Will that work better? Oh, owner terminated. Oh, okay. Result. Is the result the same? Okay, I don't know, but what I'll do, since it works, I will delete these other things right here. What was the number of jobs we had? 10,000. That's a lot. I mean, but let's just test it with 10,000. Okay. It says work received, job whatever. The thing is, how much CPU is this thing using? That's the question. And it's using 8%. 8%, I think, is one core. That's not a lot. Okay. Yes, I guess. Worker received job. Oh. Well, can I just print job? Probably something like that would be better. Can I do a reformat of this? I prefer, this is too much of an indentation. I prefer, update. I was needing that. I prefer, how to call it, only two spaces or two tab size or whatever. This is my style. I think it's a better use of space, actually. I have to restart this. Not now. Let's see if we can go without restarting this. Okay, it's better indentation. It's receiving the jobs. It's taking a while, but because it's just using 8%, we can afford to use a bit more than 8%. I will increase the number of parallel jobs to 6 to see if will that increase this thing from 8 to 16. Well, I don't know. We'll see. Let's see. No, it's not increasing. It's not increasing. That's a bit interesting because it's not working as I expected, because this is just not working as expected. Max parallel job 6. Okay, you have to do the obvious thing, right? Have to go a lot more than that. 100. Will that be something enough that for this to use more than 8%? Apparently no, it's not. Apparently is not. So it's only using 8%. Okay, let's read what I am running. Num jobs 10,000, parallel jobs 100. Here it hopefully should spawn like 100 different jobs, right? But it's not. It's not using more than one core. No matter the max parallel jobs, it is using only one core. To ensure that your program uses multiple cores, you need to make sure the threads are properly utilized and not just spawning multiple coroutines that run in a single core. Both Vlang support concurrency and parallelism, but effectively utilizing multiple cores may require affinity settings or proper distributions of workloads. You can... what the hell? You can specify the thread affinity across group for your thread functions. This is not what I mean. Why is this? Okay. First of all, this thing should be called faster. Okay, so spawn is not how it used to be. Let's see if I can find how it used to be, because previously it was working better. Okay, let's see if here we have something. It's send. Is using send. Oh, it's worker. Okay. Which one is calling worker? Workers spawn. Worker this ID. Well, this is not the actual thing that I'm searching for. Okay. Here. Spawn worker dstate. And here it says spawn worker dstate. Okay. The problem is probably here. While completed jobs is less than num jobs, worker next job divided by worker's length send next job. Receive only int. And I guess this is why this receive thing is waiting, right? So here it is waiting when it should not be waiting. I will say that receive is waiting too much, and that is probably why it is using only one thread. Okay, am I right? Am I wrong? I don't know. I'm not an expert in this. But it says, it appears that the issue might be stemming from the fact that the receive function is indeed blocking and waiting for messages which can limit the proper use of threading. To help spread the load to use your threads more effectively, you can try another approach, such as using non-blocking or concurrent message passing mechanisms provided by the language. Here's an improved codes for both Vlang and Dlang. Okay. It says main TID. Okay, now say worker, max parallel jobs. Okay, I like that. That's fine. Worker for each and workers. Next job, completed jobs. Okay. Okay, but when is this thing waiting to not use max parallel jobs? Because this is what workers use, right? I don't know. Will these limit the number of jobs to max parallel jobs? Just to check. No. What the hell? The provided examples do not strictly limit the number of parallel jobs and max parallel jobs, because jobs are dispatched as long as they are jobs left to send, and the system can process them in parallel but not necessarily limit the concurrent jobs at a point in time. To ensure that you strictly limit the number of parallel jobs to max parallel jobs at any given time, you need to implement a mechanism to keep track of the currently running jobs and ensure you're only dispatching the jobs when there are available slots. Use a semaphore to control the maximum number of concurrently running jobs. Probably, maybe, finally, this is the actual solution I was looking for. Okay. Finally. Okay, worker, and okay, I'll have a modification to the worker. Okay, of course, instead of sleeping, we have something like this. We have to do this, and instead of send the Java, we should send result. Probably. We can delete this. Now, semaphore. Do we have semaphores in D? I don't know. But probably if I happen to include this, will this work? No, it doesn't have. Okay. Forget about this. Let's forget about this. Let's try to do it manually. Okay. So here we will do something that we will receive like every time we receive, we will send a new job. Right? Well, I don't know, because here what are we receiving exactly? We're sending worker send next job. Worker okay. I'm not an expert in this. I'm just learning in the right now lots of these things. Completed jobs is there. The thing is this line right here. It says if next job is less than num jobs. And next job, how is this next job calculated? Next job plus plus. I mean, actually I should say this. Like, every time we receive this, it means a job has completed. That means we can send a new one, right? I guess. Yes or not? Actually, this is what I should do. Okay, probably. So next job would be max parallel jobs. Right? Because I am already sending this, guys. Or not? No, I'm not. What? So I'm spawning, but here sending. Difference between spawn and send. Of course, spawn creates a new process, and send, I'm not sure exactly what it does. Create a new concurrent thread task. Okay. Send. The send is used for sending a message to a thread task that has been previously spawned. It's part of the message passing paradigm where threads communicate with passing. Okay. Okay, so 0, I guess. So, because if we spawn something, and then this is waiting for this to be sent something. Okay? And it sends back the result. Okay, great. So how this is working is in the following way, as far as I understand it. First, it just creates a number of parallel jobs. In this case, max parallel jobs. Oh, I forgot this. I did it wrong. This one is the one that's 0. Next job 0. Okay. This one is the one that maybe 20. Let's say max parallel jobs 20. Okay. Maybe less than that, but okay. Okay. So we do this, and we have the max parallel jobs. We have this spawned. They are spawned. Okay. So now, what I have to do is I have to send the next job to the one that just finished. Right? To the one that just finished. So here we will probably send what should I send? Job? Job. Send back job. Okay. Okay. And this thing right here, of course, now results and will not work as expected, but the workers will have a how to say this? Workers. It sends next job. I should not send next job. I should send the worker. How to do this? I'm doing this wrong. I'm doing this wrong. Okay, I'll do this first. Then I'll do for each I is 0, I less than max parallel jobs. I don't know if this is the correct syntax. For C style for loop in D. In D. C style for loop in D. Int I 0 greater than okay. Why is it not working then? Oh, it's not. I'm not saying int. Sorry. Okay. Int. Okay, that's great. So I don't have to spawn them because they are spawned already. What I have to do is this thing right here. Okay. I have to say workers next job. Not that job. No, any of this. Just net workers. Workers I send I. Simple as that. And then here, what I receive. Where is this thing receiving? Come on. Where's this thing receiving? I forgot that. Maybe I copied to the clipboard and didn't paste it. Receive only int. Is this or is this from here? I'm really confused right now. Int runner ID or something like that. I don't know. Okay, runner ID, and here I have to do runner ID. Will this work? I don't know. Let's see. Oh, not even. It doesn't even compile. Let's see. It says template CTOR is not available. But I want to know where the thing is coming from. Okay, send Okay. Okay, that's correct. This is runner ID. Okay, that's correct. But it's not. Oh, something is doing something. Let's see how much CPU is using. It's using all of it. Okay, probably it's working. Probably it's working. Okay, now I'll limit the jobs to 3. Okay. This will be a long video, but okay. Let's see if it is doing. No, now it's 25, and that's 3. 24 is actually 8 times 3, so it's working. It is working. It's great. Okay, so this is how you do it. If you want to limit the number of jobs you have. So, of course, we can afford to use a bit more jobs. But then we will reduce this to 1000, and we will increase the max probable jobs to 5, and run it again and see how it behaves. Now it is using, let's see, what happened? Oh, I mean, because this is quite a bit of a reduction, right? Okay, 5,000. Will that be better? Will that take longer? Okay, now it's using 41%, which is something that I am okay with. And it's doing the things it does. Whatever things it does. And we have something that I don't know if this is a correct error or not. But, okay, whatever. The thing is that it finished. Okay. So basically, how this thing is working, if you didn't already notice it, we have 5,000 jobs. We have maximum 5 parallel jobs. We initialize those parallel jobs which are waiting for actual work. Here we send the actual work, but here probably we have to do something else because, or not. Well, probably not. Next job is something that we do not need here. I guess we can do completed jobs. Well, maybe. Okay. So first we send the first batch or the initial jobs, which is max parallel jobs. Now, when these guys or any of these ends or finishes, we get here, and we get completed jobs. Here we send a new one, and we send it, and it will return the same thing that we send it. And we send something here, which is I. Here it will return I, and we will use that I to identify which one finished, and so we send the next job to that runner or whatever. Okay, so that's basically how this would work. Probably here I will do 8,000, but probably not, because I don't know. The thing is that result is not returning here, right? Okay. Now, how to make the what's called worker, the worker in D return two types, two ints, for example. And you can use message passing. Mm-hmm. Here you can see how many, five different threads that it's using. As you can see, 5 different jobs. Now what's the problem? The problem is that I'm not getting the result back. That's basically the problem. And what I can do, I guess, I can send another thing here. I don't know if this will work, but I will send a result. So it will receive both a thing and then a result. Okay, a runner ID, and we'll also receive a result, which will be result plus equals received int, and it will have to print result later. Signal workers to stop. Well, I'm not very concerned about this right now, so I will just run it. Oh, what the hell? Oh. Okay. What happened? Oh, I see what could have happened. Owner terminated. Can this be the reason? Receive only int completed jobs. How to send and receive a struct with multiple members. Indeed, you can send and receive a struct with multiple members. Okay. I think this is what I'm looking for. Probably. Okay, so here we have a struct which is called my struct. Let me turn on the lights because it's late. Okay. My struct. I mean, what you can have to do as a programmer, like lots of problems and solving lots of things, but we are that. That's what we are, programmers. We do that. ToString. I don't need ToString. ID, name, value. In this case, I will say int result, something like that. This is result in uppercase. Okay. Now what I do next from here? And it says worker received, receive something, receive a struct, while true. But when it's sending a message, my struct message. Okay, I see how this works. Okay. Okay. Probably have to do it here. Probably have to create an array of structs. Okay. Struct array. This is not my struct, result. Okay. And these also have to be result. In this case, I will just do something here. Result, and this result thing will have an ID and result. Okay, ID and result. Okay, and great. Okay, so ID and result still have to int. In this case 0, which is the ID and the position of this, and result 0. Okay, then we do the same, and it has to be the same as the maximum number of jobs, which is 5, so I have to do 5. The last one doesn't need a comma, I think. And here first is the ID, then it's the result, right? ID, then the result. Okay, so first ID, then 1, I guess, 2, 3, and 4. Okay, great. Now here, what I have to do is I have to send the correct struct. In this case, what am I doing? Oh, I have to do it before here. I have to do it here. Okay, will this work? I don't know. We're testing stuff. So here, instead of sending I have to say results at I. It's not, B is not bad. Results at I. Okay, and here also I have to send results at runner ID. Result at runner ID, and here I'll do a result no, well, yes. So this is int, and now it will be result. Is this possible? Yes, I guess. Okay, now workers at runner ID send I guess I have to send the same thing, right? Probably reinitializing it. I don't like this runner ID. I will just call it R. Okay. And this result will be plus equals R dot result. Is this correct? Right. And completed jobs, send R. But here, before sending this, have to say R dot result is 0 to reinitialize it for a new thing. Or probably this thing should be done inside the worker, like here. Here. Right, and here instead of job we will be receiving a result, and here we have to do result, which we'll call R again, and result that is 0, or in this case 1 actually, you know, it's 1 for these purposes. Okay, we will delete this, and we'll say R dot result that be like R dot result, and then R dot result, and then we will send just R. Maybe we don't even have to send it, but okay, that's fine, I guess. Now, when this returns, it would be better, I guess. RID, right? I don't know. Let's see if it even works. Okay, it's using 41% of the CPU. It's using 3.7 megabytes of memory. And we're waiting. Nothing seems to be advancing. I mean, there's using CPU, that's for sure. But probably we have too many parallel jobs. We will reduce them. I was thinking of reducing them to 1,000, but yes, I don't know. This owner terminated. I don't know. Owner terminated. Okay. Workers sent through. Workers send through. Signal workers to stop. Receive. Otherwise, bool should stop. If should stop, return. This is there. Receive if is an R. Okay. I guess not bad. I think it's, I don't know if this thing is good or not, but probably it's not that bad. I don't know. I'm not really sure. But okay, so this is how you can limit. I don't know if this is working perfectly or not. But this is how you can limit a number of jobs to number of threads. Like, you don't want to use 100% of your CPU, that's for sure. Now it's done. Now let's do with 4,000 jobs just to check. And here we have 1.7 megabytes, 41% of CPU usage, because we're having 5 parallel things, and 5 times 8 is 40. And 8 is what one thread uses, so that's fine, I guess. So bool std concurrency get delegate bool outro. Oh, but does that thing return something? Oh, it returns something. But while it's not waiting gracefully, right? Because, you know, signal to stop, and then probably what we should do is wait just a bit. Okay, and we probably will wait for boolean, bool or boolean, I don't know how is the thing, bool, receive only on bool. This can do this. Okay, so here we will do this, and inside should stop we will do send true, and then we will return. Will this change anything? I don't know. I'm just improvising here. Never used this before. But I guess probably will do it will be better. I don't know. No. Apparently no. It's not the case. What should we do then? I don't know, but I'm tired, so I'm maybe not doing the best thing that I could be doing. But yes, so we're having 49% usage. We are with 4,000 jobs, 5 threads, and says process finished with whatever thing it's finishing. Main tit, send. Okay, let's see if now it doesn't crash and actually returns or prints the result, because I wanted to print the result. Will you print the result? Please. Result, okay, great. At least it printed the result. We're back on track, I guess. So yeah, I don't know how to stop them correctly or anything like that. But yes, so they bool should stop, return. Okay, I like it. I mean, I don't know if this is okay, but okay. I think this would be it for this video. I hope you enjoyed it. I will continue to try to do the same with B in the next one. So leave a like, subscribe, share, comment, and I see you on the next one. Bye.